Good afternoon, ladies and gentlemen. Thank you for coming to listen to my presentation. As discussed, I am Dan Rossiter, Senior BIM Communicator at BRE, and I'll be discussing with you data management and building information modeling. Some context first. What is building information modeling, or BIM? BIM is effectively an integrated process built on coordinated, reliable information. There's a number of different opinions out in industry where some individuals will believe that just having the software means that you're doing BIM. Others will believe it's having the fancy 3D models itself, while in actual fact it is a clear workflow and process that is needed to ensure that the information being given from one stakeholder on a project to another is clear, unambiguous and coordinated. By having this workflow and process, it means that there are a number of benefits that can be gained from a project. These include creating coordinated digital design information and documentation, things like graphical models to represent the building, non-graphical information about the performance specifications, warranty information, and other details, as well as more traditional documentation such as drawings, reports, schedules, and specifications. If a good integrated process has been used, it can help with predicting performance, appearance, and cost. And this is reliant on the fact of having a good, consistent workflow being integrated into the process, as well as the ability to deliver projects faster, more economically, and with reduced environmental impact. Now, the core premise behind this is the ability to improve efficiency while reducing waste. And we're not talking about material waste from the buildings, but rather a resource waste within the process. The idea of reducing abortive or overproduced work to ensure that the right information is given to the right people at the right time. And that is effectively the core of the BIM process. So to reiterate, it is not just about 3D CAD. You cannot purchase 6 copies of a piece of software and claim you are doing BIM. It is about a cultural way of applying an integrated process and collaborating with other team members. It is not a new application of technology. A number of the processes within BIM were actually written up in the 70s and 80s, and all they've done is been reflected and revised to suit the technology of the time. And there are a number of really good case studies from the 80s and 90s that show that good collaborative processes can help achieve savings on projects. And ultimately, it's not the next generation, it's here and now, as people are able to do it and are doing it well. BIM is essentially about value-creating collaboration, and by doing so, you're able to exchange good models, intelligent information, and documentation about a project. Effectively, when I speak to people about BIM, I try not to think of it as building information modeling. I try instead to think of it as better information management, as the core part of it is to focus on the information that you would normally provide, but to enhance it to make sure that those who use your information know that it's clear, complete, and unambiguous for their needs. As part of the BIM process, there are a number of key stages that need to be completed. Shown here are the first few steps in the process. Starting from the top right and moving anti-clockwise, you begin by defining the employer's needs. As Ola mentioned in his presentation, there are issues where owners' requirements are far too fluffy, and there's a lack of measurable requirements being put in place. Through the BIM process, there is a need to define the employer's information requirements, which actually include information needed by the organisation and information needed by the teams who will be managing that asset or building. This is the opportunity for them to clearly define what their needs are in terms of what data or measurable outputs are required as part of their processes. At the same time then, as part of the procurement process, there's a need for the supply chain to look at those requirements and respond back to them in a clear and accurate way. For example, if the employer's information requirements asked that you provided certain bits of information at the end of each project stage, you'd expect to see this reflected in the BIM execution plan, effectively having the supply chain mirror the employer's requirements and respond back with how they plan to deliver them. And finally, once a preferred supplier has been appointed, they are then able to write their master information delivery plan. This is a schedule of all the items of information that will be produced, incorporated into a design program or an information release schedule that specifies all the information that will be produced and the order it will be produced in. This means that the actual team itself has a clear set of requirements on how to do their work. This is a massive undertaking which is very resource intensive, but means that from the outset of the project it is clear what information is needed, by who and when. When describing this process, I'm always reminded of a quote by Abraham Lincoln, which goes along the lines of, "If you give me 6 hours to cut down a tree, I will spend 4 hours sharpening my axe." It is the idea of preparing to ensure that what you do is right first time. And this is a core part of this BIM process. Without good owner and employer investments and clear requirements from them, the efficiency and improvements you can get through the BIM process will be severely diminished. Once this process has been undertaken and the supply chain are sure on what they need to produce and how, they enter a mobilization period to test this information. This is to ensure that they're able to send this information back to the employer in an efficient way. It's been split up into 2 sections. The red diamonds you can see at the bottom of the screen are referred to as the employer's decision points. These are when the employer or owner needs information, specified within their employer's information requirements. The BIM execution plan then, using the master information delivery plan, specifies the supplier's information exchanges, those green diamonds. At this point then, for each project stage, you're able to have a communication between the supply chain and the employer to exchange any information that was needed as part of the project. This means that as you produce your information, it can be gradually developed in line with graphical models, non-graphical information and documentation to ensure that information is reflective of the owner's needs. As you can see here, at the end of each work stage, for example, at the end of stage 2 concept, there may be a need by the employer to receive certain information that needs to be supplied by the supply chain. Should they not actually provide this information, then that work stage has not been completed and the project will not progress, providing elemental opportunities to specify and receive information throughout the project. Now, as part of this process then, there are a number of different terminologies in use. Through the design and construction stages of the project, it is known as the Project Information Model, or PIM. That's all the information being produced by the designers and suppliers. However, following the handover of information, once the project has been completed, there's a need for the employers and owners to maintain and look after this information, and this is done within the Asset Information Model, or AIM. This exists outside the project and should be looked after during the operational and use periods of the project, meaning that this information needs to be looked after properly so that in the next 10-15 years' time, when a new project begins, they can rely on good, accurate information to begin that project. Now, as part of this process, within that diagram, you have what is known as the Common Data Environment. This is a shared repository of information to be managed throughout the project. Each of the different designers, engineers, specialist subcontractors have access to this shared resource to be able to receive and exchange information on the project. For example, the architect might put his ground floor plans there, the structural engineer could put his grid lines, calculations and structural models on there, while the acoustician could put his acoustic report. And then this information is available in one singular place where you know where the most accurate information can be found. In here, you'd expect to see a mix of information. And this includes graphical models, such as the kind of thing you might expect from ArchiCAD, Revit, or MicroStation, these kind of object-based models, but they can also include flat two-dimensional models also as part of this process. The second part of it is to have some kind of non-graphical information. Now, this information can either be embedded into the model and actually then linked to the specific objects directly, or associated to those models via external databases. If you're using some form of database specification system like MBS Create we have in the UK, for example, that information doesn't exist in the model, but in a separate location, but has a relationship with the model, so that any changes in the model are reflected in the specification. And then finally, there's a need to include any of the standard documentation you might expect as well. Now, interestingly, in the way that it's meant to work is that there's a relationship between each of these items, and that normally non-graphical information might come from the graphical model, and that mixture of the non-graphical information and graphical models can be used to produce drawings, schedules, and reports. This is typically done through some kind of exchange procedure. For example, what's been shown on the screen is a method of exporting information from the graphical model into a non-graphical format. What's been done here is that the standard model, which was done at the time using the Autodesk software Revit, was then exported out using the IFC model view definition for facility management handover, effectively a filter on the information that removes any of the non-relevant bits and focuses on the information needed to manage that particular building or asset. For example, that will include things like the make and model of objects. It will also include warranty information, as well as items such as potentially the assessment criteria, whether anything's in good condition or not, can all be recorded within the system and then exported out into a standard structural method within an Excel sheet or a CSV file or some form of SQL, thereby having numerous different ways where the information can be exported out, but done in a structured and consistent way. As part of Ollie's presentation, he mentioned obviously with a lot of subcontractors potentially inputting information, there's a need for a structured way to do this. By using something like the IFC Industry Foundation class, an open data format for structuring construction information, this can be done in a consistent way where the same names for attributes and the same data types can be used, so that it's easier to combine and federate information to produce a single collated source. This also means you're more likely then, when receiving updated information during the operation phases, that that's in the same format and it needs a little configuration to be passed forwards. A key part of this process has been the idea that we take the graphical model, filter information out, at which point then it creates the non-graphical information, such as the example we've got here, which is COBE. Now, with COBE, or Constructing Operation Building Information Exchange, there are a number of different elements that are relevant to building commissioning. For example, within the design phase, there's a number of bits of information that is recorded as part of this process, as is in the building stage, where you collected information during the job, and finally, during the common stages, whereby there's information around contacts and other information that's getting collected. As part of this process then, it's not only the physical elements, but any resources and activities associated to them, as well as who has been assigned to do what, and any associated documentation. Which means that COBE itself is quite a structured and well-formatted way of presenting information to make it suitable for the management post-contract, as well as in regards to collecting information about the project and building commissioning. For example, these key areas here will include a lot of the relevant information needed in relation to the commissioning of elements. For example, under the type worksheet, information about the actual manufactured object and its specification will be included. This will include information such as the size, colour, shape, specification, as well as any warranty duration and particular details around the warranty of those objects. In addition, the component element will actually tell you about that unique instance, meaning that it will include the location, which room it is in, as well as any installation details, the unique asset tag for that particular item, and who has done the installation. As well as the system element, which actually records the part of which system these elements are part of, be it the heating control elements, the fire alarm systems, or whatever. It'll actually then identify what components form part of that and what types those components have, allowing you to trace the objects through the system to identify which ones are the relevant objects. From the Common tab, there's lots of good information from the documentation and attribute side. Through attributes, you can include additional information that isn't already included within COBie. For example, this could include assessment details, if any property condition surveys have been done, any energy performance information included in there, or anything required by the client or the asset management team in particular to ensure that is captured and collected properly. With the Documents tab, it allows you to capture information associated onto other documents. For example, the test records from the commission witnessing could be included, the actual documentation identifying the warranty, any standards, methods and procedures by the manufacturer on how to do any of the seasonal setups and decommissionings for those particular assets can all be included and then referenced as part of this, providing a structured way to provide that, meaning that it can be an automated process to put this information from COBie into any shared resource system or computer-aided facility management system, providing a good, consistent way to take this information and use it in a consistent manner. Now, the way that it's been structured is that it's very particular on how information needs to be set up, which means it helps to define standardized processes and a more transparent way of doing things, such as identified by Anita at the introduction section of this webinar. By having it in such a structured and transparent way, it means it's more consistent to produce this information. For example, as part of this process, it'll actually define how the data needs to be displayed, and you are able to test and validate whether this format has been used properly. For example, every system must have a unique name, and if any of them have any duplicates, there will be an error within the system and it will not be able to be read. Information is taken from other areas. For example, the person who designed the system will be listed in the created by, while the category and component elements will be pulled from other attributes, providing a clear and consistent set of information throughout. Dates must be put in a certain format, meaning that any installation dates, any certificate dates and everything else will be put consistently throughout the project. I believe a fourth Y for year should be on that presentation. I apologise. But as part of it, there's a clear, consistent way of doing it based on international standards. And finally, there are automatic attributes that come through, and then more qualitative information to actually identify things in a human readable manner, meaning that it's not just machines that can value from this information, but people can too, which are the main users of this final information. For example, in the document sheet, you may get information about a certain inspection report, which will have its own unique name, identify who was involved in the process, the date at which it was created, what kind of thing it is, the report, who was approved it by, what stage was it done at. So particularly when Ollie was mentioning about this idea of a commissioning process throughout the project's life cycle, you can then identify it by certain work stages, meaning that information can be shown, which is effectively the same bit of information progressing by each work stage. You can identify the systems it relates to, identify where the documentation is, and then actually describe each of these bits in a clear and developed manner. And this means that throughout the process, so long as each person conforms and complies with this system, it means that there is actually a very quick way of able to be exporting and importing information in a clear and standardized manner. Now, as part of this process, it's realized that for the early stages of a project, the owners and asset management teams typically don't consider the information in such a finite detail as I'm describing here, which means that should they not actually describe it in a sufficient way, it may be difficult to receive it in such a consistent and well-structured manner. As part of this, and the way that the UK has defined what it's doing for its BIM Level 2, and the same information is being put forward into the international standard ISO 19650, the idea is that there's a number of different sources of information for the initial parts of the project. The idea and methodology within BIM is to start with the end in mind. And if you know what information you need to receive at the end of a project, you need to be clear on what your specification is at the start of a project. For example, here, and in relation to what we're talking about, the two key elements are the asset information requirements, the AIR, and the asset information model, the AIM. As part of this process then, the asset management or facility management team will specify what information they need about each of their elements and components. It could be, for example, that for doors and windows, all you really want to know is the make, model, and manufacturer, while for some of the more complicated business service-based elements, there might be a lot more information you want, such as outline specification, design intent criteria, as well as final product performance declarations. As part of this, you can specify that within the asset information requirements, and they're fed into the employer's information requirements to become contractual requirements. Because they've been placed and they become contractual, they are then used as the pass or fail criteria for the project, meaning that they help specify how the information is produced from the early concept stages to final handover. As such, this information is developed in a gradual and consistent way, meaning that towards the end of the project, all the information should be there, as opposed to a last-minute scramble to produce all the O&M information and the final commissioning information. It's been developed gradually and consistently throughout the project. Finally, when the information is handed back to the owner and employer, they then are able to refer to their original requirements and test it against the information model. This means as part of this system then they're able to compare what they originally specified against what they received, and then use that as the criteria on whether they're willing to accept this information or not. As it's been specified as part of the contractual requirements, you are then able to use your power through the contract to say they actually haven't met their requirements and could withhold payment or go through whatever relevant clauses you have specified to deal with such a situation. This means there's greater security that you'll receive this information, and that by specifying it properly at the start of a project, you gain benefits from receiving it towards the end. For example, here is a screenshot of some information produced by the UK's Ministry of Justice to identify what information they need about various elements and components from projects that they specify. As you can see here, there are a number of items on the left-hand side, which include boilers, evaporators, pumps and other systems, and the information they want to receive from the supply chain as part of their asset information requirements. This information is then included within the employer's information requirements as contractual, and then they're able then to check the information they receive to ensure that this information has been included. By providing clear information such as has been shown, it means that you're able to identify what's needed for the project, ensure that it's being produced as part of the project, and then receive that information in the format that you've specified. In summary, the building information modelling is a process used to structure information in order to represent an asset and its information digitally. By collaborating and using a single, transparent, coordinated process, each disparate member of the supply chain is able to produce consistent information, meaning that when you pull this information together, it follows a single structure, allowing you to combine and configure this information with little effort. By specifying structured information such as through the Industry Foundation class and Open Data Schema, information can be produced in a consistent structure, which means that you can both validate, ensure the information is there, and verify, ensuring that the information is in the correct format. For example, whether the date is in the right settings, or whether certain fields require integer values instead of binary yes/no values. And ultimately, using something like COBE, which is really a subset of the Industry Foundation class, information about the commissioning systems and the elements they relate to can be inputted in a clear, structured way, as well as any associated documentation, meaning that if it's exchanged throughout the various design stages, construction stages and handover, information can be handed over consistently throughout the project around the building itself and its commissioning systems. Thank you.
Thank you, Dan. So we continue right away with the final presentation. So I hand over the floor, or give the floor to Stefan Plesser, who is also coordinator of the Quantum project on behalf of the Technical University of Braunschweig and CEO of Synavision, consultancy company dealing with quality management of